Today we're going to discuss analog input. Now you may be aware and remember that we talked previously about digital input and digital output, and there are other lessons on that if you're interested in reviewing those. But today it's going to be about analog. So what is analog and how is it different than digital? So let's just talk about this for a moment. So digital, when we talk about digital with respect to the Pico, what we're really talking about is digital is a value, so it can be an input to the Pico or an output from the Pico, and it's going to have two values, one of two values. And those values go by many, many names. So one of the values, you can think of it as the high value. You can think of it as a 1. You can think of it as a Boolean true. You can actually think of it, its actual voltage for the Pico is 3.3 volts. So all of those is the same name, different names for the same concept. On the other hand, the opposite value is low. We would think of that as a 0. We would think of that as false. And the voltage associated that with 0 volts, or you might also think of it as ground. It amounts to the same thing. So two different options, and that's great when you're dealing with something that's either on or off. Let's say that you're reading a signal from the outside world into your little Pico. Maybe it's a button that's pressed or not pressed. Maybe it's a switch. Maybe it's something that triggers a response, like if someone walks in front of an ultrasonic sensor and you detect that. But sometimes you need to measure something that has a continuous value. Let's say, for example, that you were doing a temperature. So let's say that you were creating a little weather station application, and here's your time, and this is your temperature. The temperature may start out in the morning low and then peak in the early afternoon and then go back down again. There's no way you can really represent this information with a digital value. So instead, that's where analog comes in. Now, an analog is a continuous range of values. And on the Pico can measure a continuous range of values. And when I say values, I'm really talking about voltages from the perspective of the microcontroller. Now, this is very, very important. When you are dealing with a Pico and you're putting a voltage into it to measure, it is important that your range starts at 0 and goes no higher than 3.3 volts. It can be any value between these, but it cannot be higher than that, or else you're in danger of actually destroying your microcontroller. All right. Okay, so let's go ahead and look at a way that we can measure this. And so the first thing I'm going to do is I'm going to create a source of voltage that I can vary between these values. So one approach that you can use is you can actually create a voltage divider. And we did discuss this back in the first circuits lesson. If you want to review that, that's fine. I'm just going to describe it quickly here. So a voltage divider is a system that allows you to output a voltage that varies between two values. And that's exactly what we need for this case. So we're going to build a voltage divider, and we're going to route its inputs into the Pico and measure it with its analog input capability. All right, now if I draw a circuit diagram for the voltage divider, then first of all, we're going to have a high voltage. And if you will recall, there is a pin on the Pico, and it is called the 3V3 out. This provides 3.3 volts out at all times when there's power applied to the Pico. So we're going to use that, and I'll just label it just like it's labeled on the Pico, 3V3 out. And then it's going to go through something that we call a potentiometer, and then it's going to go to ground. And the potentiometer, it looks like a resistor so far, but there is another leg to it that looks like this. And this here represents, this thing right here with the 3 inputs actually represents a potentiometer. This is one example of a potentiometer. There's actually quite a few different varieties of them, but notice that it has 3 legs. So the top leg, or it doesn't really matter which way you orient it, it'll just affect the way that you turn the knob. The top leg can go to the 3.3 volts. The bottom leg goes to the ground. And the idea is that the middle leg, which represents here, this is voltage depending on how you twist this knob, will go either all the way to 3.3 volts or back or down to ground with any value in between. All right, so this right here is where we want to measure the analog input on the Pico. So it turns out that the Pico, and this really depends on the type of microcontroller that you have, but on the Pico, there are actually only a few pins that can measure in an analog value. And they are here on the right-hand side by with the way that we've implemented it, the way that we've put it into the breadboard. And here they are. They are ADC 0, 1, and then skip this guy and go to ADC 2. All right, so ADC actually stands for analog to digital. And you don't need to worry too much about what that means. It's just that when a microcontroller measures an analog signal, it needs to eventually, inside of its inner workings, translate it into the binary code that it uses. Okay, so using this again, I'm just going to pick one of the pins, and it's going to be pin 26. And so I'm going to write that here. And the other thing is, remember that when you're picking a pin on your Pico, if it is on a breadboard, you're going to need to figure out which pin it is on your breadboard. That's the purpose of this label right here. It is 10 on the right-hand side of the Pico. All right, so let me go ahead and wire this up according to our diagram right here. The first thing I'm going to do is the 3v3 out. And by convention, I use a red wire when I'm hooking directly to a positive voltage. So this is a 3v3 out, is at location 5 on the right hand side. So I'm plugging that in into 5 here. And I can do this anywhere where I have some free space down here. So I'm just going to go and put it here. And let me get back my little potentiometer. And so there are 3 legs. The top leg I will connect here. So you have to be careful, make sure that your leads hook up to the right row. Remember that all the rows, all the slots in a row are connected. So I'm going to connect it like this. And be careful, easy to bend these little legs. They're kind of fragile. Okay, I think that's in there. I guess we'll find, oh, let me try that again. Oh, it looks like it went in the wrong leg. Okay, so let me try that again. There you go. Okay, so there it is. And then the opposite side, so skip the middle leg for now. It's going to go to a ground. You can use any ground. I'm just going to use the one that is on pin 8 right here. So pin 8 is a ground. Sorry, it's not called pin 8. It's just labeled ground. It is on slot 8, location 8 in my breadboard on the right hand side. Okay, so now here it is. And now I just need to measure, to route a, to get a lead that goes from the middle leg to the pin that's going to measure that input. All right, so I'm getting this blue wire. I'm putting it in the, connecting it to the middle leg. And now I'm going to route this. Now, where should that go? I've decided I'm using 26, which is location 10. So I'm going to go to 10 here, connect that up, and that is our circuit. All right, let's jump over and start looking at our Thani. Now, remember that when you write a Thani program, there are 3 different things that you need to do. The first one is that you need to actually do all your inputs. Sorry, not your inputs, but your imports. So we're going to bring in, well, actually, I need to actually create a file. So I'm going to do new, and I'm going to call this import. And you might remember, the way that I like to do it is from machine import pin. That should look familiar. We've done that with our digital inputs, but now we're adding in another import, which is ADC. Sometimes these names are not intuitive as you might like, but you just kind of learn that that's what they mean. ADC refers to the analog inputs. All right, now I'm going to go ahead and let's start programming this. So the first thing I'm going to do is I'm going to identify my pins. So the first part is importing the software that you're going to need. The second is let's identify the pins we're going to use and explain to the Pico how I'm going to use them. So I'm just going to name my pin ADC, and you can name it anything that you want. And the way that you tell the Pico that you're going to use it as an ADC is this way. You use the ADC keyword, all capitalized. Capitalization is important. And then you do pin, so we're using the pin as well. And you pass in the number of the pin you're going to use, which we decided is going to be 26. Okay, so that's setting up. And now you have the actual program itself. So I'm just going to create a little bit of a loop, and I'm going to read the value and print it out. That is a great start. If you can do that, then now you can use that value in any way that you want. So I'm going to do while true. And the first thing I'm going to do is I'm going to read the value. And you know what? I'm going to save the value in a variable. So I'm going to say value is equal to ADC dot read. That makes sense. And then it's followed by U16. Now, U16 is a little bit confusing, like where did this name come from? And it's not important to understand this thoroughly now, but basically what it's saying is that the number is going to be a 16-bit number. Under the covers, Picos, like all other computers, microcontrollers, etc., use binary. This is a really interesting topic, and I do encourage you to look into it further. But for now, we just know that this is going to read in a value from our voltage divider. Now, I'm just going to actually print the value like this, and I'm going to put in a little bit of a delay. So remember that that's sleep, and I'm going to put in 1/10 of a second. Now, this is not going to run because if I use the sleep method, I need to make sure that I import it as well. So from time import sleep. All right, I'm going to save this. It's going to ask me which thing to save it to. I'm going to put it on my Pico, and I'm just going to call it analog input.py. Notice the naming conventions I'm using. This is standard for Python, all lowercase. If you have more than one word, join it with an underscore. You cannot have spaces in a file. Oh, that's not a good idea. Okay, so there it is. And now I can run this and let us see what happens. You'll notice that there is a bunch of numbers streaming out. Now, you won't be able to see this, but I'm going to take that knob and I'm going to twist it in one direction. And you'll see that those numbers are definitely getting bigger. And you might even see, okay, the maximum number, I've twisted it all the way one way, the maximum number happens to be 65,535. That is a strange number, but that is the maximum number that can be read when we use this read underscore U16 method. All right, if I twist it all the other way, then I get down pretty low, but I don't go all the way to 0. Sometimes that's just the way these things work. Okay, so another really, really useful thing that you can do in Python is if you go, in the Thonny integrated development environment, is you can go and view, and if you turn on something that's called the plotter, here it is right here, then it actually will generate a plot of the numbers that you're printing out. And this works even if you're printing out more than one number. So I often will use this when I'm dealing with the signal and I want to see its response to changes. So now I'm going to go ahead and twist this knob, and you notice that as I twist it to the right, it goes up. I twist it to the left, it goes down, and I can just make little waves. So in conclusion, the analog input allows you to measure a voltage coming from external sources that varies between 0 and 3.3 volts. Now, why is this useful? There's many, many situations where it is a case. For example, you might be measuring the output of some kind of a sensor. It might be, it might be a temperature sensor. It might be anything that creates resistance. You can create a voltage divider and convert a change in resistance to a voltage value that you can then measure and have your Pico respond to that in some way. Another thing is you can always use a simple potentiometer, create your own voltage divider, and use this to control something. For example, you might have the change that the variation here control the rate of the turning of a motor or some such thing.